Today we're going to take a look at inscribed angles. Inscribed angles, before we get going, we need to know what they are. So an inscribed angle is simply an angle whose vertex is on the circle. Another definition that we're going to want to know is the intercepted arc. We've been talking about intercepted arcs. They're simply the arc that is formed by an angle whose vertex is in or on the circle. So in this case here, our intercepted arc would be AC. All right, let's jump into these theorems, these truths about inscribed angles. This is called the inscribed angle theorem. It simply says that the measure of an inscribed angle is half the measure of its intercepted arc. So here is angle ABC. Its vertex is on the circle, therefore it's an inscribed angle, and therefore the measure of angle ABC is going to be equal to 1/2 the degree of this arc AC. So if I gave you an example and I said to you that this arc AC is 80 degrees, then you would say that this this inscribed angle B is 40 degrees. A corollary to that says that if an inscribed angles of a circle intercept the same arc, then those, are subtended by the same chord or arc, then those angles are going to be congruent. And it simply means this. Here's a few inscribed angles. Here's angle AFC. Here is angle ABC. And finally, here's ADC. All three of those angles, and I'm just going to color them in here so you can see them, they all have the same intercepted arc. I'm going to highlight that in yellow. Here's that intercepted arc, AC. Therefore, since they all intercept the same arc, they must all be congruent to each other. Therefore, angle B is congruent to angle D, and it's congruent to angle F, and they are all equal to 1/2 the measure of arc AC. Next says the inscribed semicircle. An inscribed angle subtends a semicircle if and only if the angle is 90 degrees. Because our intercepted arc here, it really should be ADB, is 180 degrees, then this angle must be half of it, which would make it 90 degrees. And therefore, it subtends or intercepts this semicircle, and therefore angle C must be equal to 90 degrees. And finally, our inscribed quadrilateral says this: if a quadrilateral is inscribed in a circle, then then its opposite angles are supplementary. And remember, supplementary means that they add up to equal 180 degrees. So opposite means they're not adjacent, they're not consecutive. Opposite would be like angles X and C. So angle X plus angle C would be equal to 180 degrees. Likewise, we'll change colors here. Angle B and angle D would also be equal to 180 degrees.
Let's try a few examples. In this one, it says to use our inscribed angle theorem to answer the following questions. It says find the measure of arc PS and the inscribed angle PRU. So inscribed angle PRU is right down here in this corner. And I see that it's inscribed and its intercepted arc is 118. Therefore, the relationship between the intercepted arc and the inscribed angle is 1/2. I need to take 1/2 of 118, and that's going to give me 59 degrees. Therefore, the measure of angle PRU is equal to 59 degrees. Likewise, if I take a look here, I see that this angle SRP is 27. Now going from the angle out to the arc, I'm going to have to double it. So take the 27 degrees, which is your inscribed angle, and multiply it by 2, and now this will give me my arc measure. In this case, this arc measure will be 54 degrees, and that's the arc of PS.
In example 2, it says to use the corollary and find the measure of angle LJM and arc LM. Well, if I take a look at my picture here and what I'm given, I see that this angle LJM is right here. It's this tiny one, and it intercepts this arc LM. Well, if I take a look here at LKM, I see that this little tiny angle here also intercepts the same arc. Well, two inscribed angles that intercept the same arc must be equal to each other. So 5b minus 7 is equal to 3b. I'm going to subtract 3b from both sides, and that gives me 2b, and now I need to add this 7 over to the other side, which there's just 0 there. So if I add 7 to 0, I get that. I get 7. So b is equal to 7 divided by 2, which is 3.5. Now I can go back and use the value of b to find the measure of those inscribed angles. So I'm going to take 3.5 and multiply it to 3, and that's going to give me 13.5. So 13.5 is the measure of angle LJM, and that's also the measure of angle K. And now I'm going to, let's see here, did I do that right? 3 times 3.5. Yeah. And that's going to give me the measure of angle K. And now I know I can find the measure of arc LM. Arc LM must be twice the inscribed angle. Therefore, if I double it, I will come up with 27 degrees. In our next two examples, we take a look and we say, and we see that we're going to use the inscribed semicircle theorem. It says to find the value of A. Well, if I look at the picture, what I'm given is I see that my diameter, WY, because it goes through the center of my circle, and I have an inscribed angle, Z, and it goes through the endpoints of that diameter. Therefore, it inscribes this semicircle. And because it inscribes that, it must be half of that semicircle, which would be half of 180. So therefore, this angle measure WZY must be equal to 90 degrees. Well, if I want to find the value of A, I'm going to set these two equal to each other, and I'm going to work to find, I'm going to work to get A by itself. So I'm going to subtract 20 from both sides. That becomes 5A is equal to 70, and I'm going to divide by 5. When I divide 70 by 5, I'm going to end up with 14. I had to check my notes, and there you have it. There's the value of A. In our next example, we're going to use the Inscribed Quadrilateral theorem. It says, find the measure of the angles to, in the quadrilateral. Well, I have this quadrilateral, HIFG, and it's inscribed. That means all of its angles are on the circumference of the circle. And I remember that opposite angles are supplementary. Therefore, I know that 8M and 10M must add up to equal 180. So I'm going to start there with those two angles that I know. Set those equal to 180. That's 18M equals 180, which would make M equal to 10. Now I can go back and find the value of each angle. So angle H must be 5 times 10, or 50. I is going to be equal to 80. G is going to be equal to 10 times 10, which is 100. And what about angle F? I know that my opposite angles are supplementary. So if angle H is 50, angle F must be 180 minus 50,